what makes it different from other species? Where do individual kinds of living things occur? What species are collectively in a place? How do individual species respond to their physical environment? And how do co-occurring species interact? So while this may be basic biodiversity research and these may seem like simple questions, each of these has whole subdisciplines of biology related to it: taxonomy, biogeography, floristics, odd ecology, and community ecology. And based solely on my preferences and my training, these are the two of these that I'm really going to focus on for the first part of this talk: taxonomy and floristics. So taxonomy. I mentioned that this is a subdiscipline that kind of includes the question, what makes a particular species distinctive? But there's lots of activities that fall within the umbrella of taxonomy: description of new or existing species, identification of new or existing species, so kind of developing the tools that help practitioners and lay people take an unknown thing and identify it, the classification of groups of species. So this is where you might take a handful of species that look alike and group them into a genus. You might group those genera together into families and so on. So that's classification. And then nomenclature is the formal set of rules that govern how we name things in kind of Western science. So that's the discipline of nomenclature. Now, I want to point out, taxonomy is absolutely critical to have done in the past and to do now and in the future. It's critical, if for no other reason, that nearly all conservation activities are tied to formally recognized named entities. So, for example, the Federal Endangered Species Act, it can work with subsets or population segments, but far and away, the most common way that ESA protects things is protecting a rare named taxon. So this taxonomy business, it's something that is really, really important to continue to do. Floristics. So I said floristics would encompass the question, what species are collectively in a place, but lots of activities fall within floristics. At the most basic, it could be field work, exploring an area, documenting it, documenting that area formally with specimen collection. But it can really be a lot bigger project than that, and it could end up being something like the formal description of all of the plants of an area, the flora of an area. And that might take the form of a scientific journal article or a reference book. So we have a bunch of great reference books and a bunch of great products that have resulted from the floristic activity on the California Channel Islands. Flora of San Nicolas Island, I'm showing the cover of that here by Steve Junak. This is a 2008 book. Floras like this are really enduring resources. They represent a snapshot in time for our knowledge of the biodiversity of an area. It could be floras, of course, pertain to plants, but it could be the fauna of a particular area, really carefully documenting the beetles of San Clemente Island or something like that. These are just really, really critical outcomes of floristics work, a kind of basic biodiversity research. Okay, so why does this basic botanical research matter? Why should we care about the individual units of biodiversity like Malva acergentiflora on Santa Rosa Island, or the communities they form, like this beautiful Opuntia patch on San Nicolas Island? Why does it matter? Well, quite simply, plants are the foundation of terrestrial ecosystems. They are that primary producing, hardworking group of organisms that are master organic chemists. They've figured out how to harness the energy of the sun to create organic molecules. And those nutrient-rich molecules are passed up the food chain or throughout the food web to consumers, right? So literally all life in terrestrial ecosystems depends on the hard work that plants are doing. We ought to care about them for that reason. But they do important work for all living things. Plants are responsible in part for the breathable air, oxygen in the air. Plants are responsible in wetland settings for slowing down the velocity of water, helping to filter water. We know firsthand here what can happen when we don't have soils, when we don't have plants stabilizing the soils. After a fire, for example, we really can appreciate the vital job that plants are doing at soil retention. And I would challenge anybody who's listening right now to say that they didn't interact with plants as natural products at some point today, or even right now. I'm looking down, I'm wearing a cotton t-shirt. I had rice in my lunch today, and the starting point of almost all medicines is a natural product, often from plants. So plants are the basis of the food web, the basis of terrestrial ecosystems, but they're also doing these hugely important jobs for all living things. Now we know biodiversity is really facing unprecedented challenges, right? One way that we've begun thinking about this is encapsulated in the work that Conservation International, an organization, has done in recognizing global biodiversity hotspots. So these are areas that are really special biologically, but that are facing major threats or challenges. The criteria for global biodiversity hotspots are that these regions must have greater than 1,500 endemic species. That's the special biologically part. And then they must have lost at least 30% of their natural vegetation. There are 36 of these hotspots on Earth. You can see them depicted up in the upper left here. They represent only 2.3% of the Earth's surface, and yet harbor over 50% of the Earth's plant species. So these are real special places. The California Floristic Province, where we're sitting right now, extending from southwestern Oregon down into northwestern Baja California, is one of these biodiversity hotspots. Nearly 2,300 endemic taxa. This is an ever-evolving number, but well over 2,000 endemic taxa. And staggeringly, we've lost over 70% of our natural vegetation here in California. So really a special place and undergoing large challenges. If this is something that you want to dig deeper into, the habitat loss component, there's a website that is set up to study and present these data to the public. This is disappearingwest.org. And you can see here in this map of California by counties, areas that have had the most loss in the hottest burning colors here, relative to those that have the least amount of loss in the cooler colors. And if we were to look at this in a tabular format, this is, again, Disappearing West, so it's focusing on Western North America. These are the states that they're thinking about. California, over the time that they were monitoring, so this is 2001 to 2011, lost almost 800 square miles of natural land. And while this is not the largest by percentage, it is the largest overall number on this table. Just really a staggering amount of change. Invasive species are also a real big deal. If you want to learn more about invasive species, you can go to the URL in the bottom right. This is the Center for Invasive Species Research out of UC Riverside. They estimate that 6 new non-native taxa, potentially invasive, arrive to California annually. And this has a huge economic impact in California, over $3 billion a year spent on invasive species control and eradication. And the US government estimates that 42% of endangered species became endangered in part due to invasive species. So this is a big deal. And it's this evocative image, you really don't need to say anything when we're thinking about this. All of us have likely lived through increasingly large wildfires that are attributed almost directly to human-caused global climate crisis, which is altering the amount and the kind of tempo timing of precipitation events. Of course, temperatures going up, sea level is rising. It's a big mess. So what can we do? It almost feels ridiculous to have a floristics and taxonomy slide after those 3 biggies, right? Habitat loss, climate change, invasive species. And sometimes when I make this argument to people, they respond back with, well, I mean, Matt, what's left to know? Aren't there more important things to be doing with our time? And they're oftentimes equating floristics and taxonomy with this sort of Victorian naturalist kind of pursuit. As a bit of an aside, almost at least half of the naturalists I know today look just like those 2 people on the left. I half the time look like those 2 guys. But anyway, they think of this as sort of a Victorian naturalist thing. Is this just glorified stamp collecting? Aren't there more important things to be doing? So I want to address that very specifically. And other people want to address it too. Kew Royal Botanic Gardens, this is based out of the UK, largest botanic garden and largest herbarium on Earth. In order to combat this sort of biodiversity blindness, puts out a state of the world's plants every 3 years. And in 2017, They let the world know that they tabulated 1,730 plant species were described in 2016 alone. That's the year that predated their report. Just a staggering amount of biodiversity that was up to that point completely unknown. That's 0.5% of all plants named ever in the history of Western science, naming things, were described in just that 1 year. Really pretty sobering. 3 years later, the next Q, State of the World's Plants and Fungi in 2020, 1,942 plants and just about the same amount of fungi named for the first time in the preceding year, 2019. And again, that's about 0.5% of all described taxa on the face of the planet were described in the course of just 1 year. Okay, Matt, well, that's worldwide. Maybe that's the tropics. What about California? So this is a figure that was taken from Barbara Erder's great paper in 2000 that focused on this issue specifically. And so this is on the x-axis is year, and on the y-axis is number of new taxa described in that year. And so this goes from roughly when we Western science folks started doing that job, slightly before 1800s, up to 2000 when she wrote this paper. And you can see, certainly around the time, that sort of Victorian naturalist stamp collecting era that people envision, there was a huge swath of California's biodiversity was described. This is the Edward L. Green, Alice Eastwood, Willis Lynn Jepson hump right here. So a huge number of things were described there. But what I want to draw your attention to is look at over here. I mean, biodiversity description continued apace from when Willis Lynn Jepson was winding down all the way through to when Barbara Erder was writing that paper. There's another way to look at this. This is from Dean William Taylor. So instead of the number of species per year, this is a species accumulation curve. So in each year, we're adding that year's new things onto the years that preceded it, right? So we should be climbing upward. So that's what this orange line is. Dean went through and tabulated for every year. He did this accumulation thing, and this is where we are. Now, Dean did a very cool thing. Dean realized that this could be modeled, and he went ahead and fit a curve to this. And this, the difference between his model and where we left off when you project that model into the future, I'm calling that our biodiversity blind spot. This is a shocking number. So if we do that, if we calculate this difference, that's around 500 or so undescribed plant taxa in California. So just absolutely shocking. And it wouldn't be too cheeky to go ahead and put that in red. Like, that is just a huge number of plants yet to be described from California. A very, very important blind spot. So when you're driving your car and you're thinking about a blind spot, we have tools that help us to understand that, right? We have these side mirrors and stuff like that that help us know what's in our biodiversity or in our car's blind spot, right? But what's in our biodiversity blind spot? We just don't know. Is it acceptable to have a biodiversity blind spot at all in this time when we're making these, when biodiversity is facing these unprecedented changes and we're making decisions, certainly in the absence of all of the data? So that's pretty sobering. There's another way to look at this. So those were taxa that need to be described. Here's what I'm calling Santa Barbara County's botanical black holes. So this is specimen data from about 9 years ago, so it's a little bit dated. But just kind of soften your gaze and look at the map of Santa Barbara County. Don't look at the islands; those look pretty well collected when you look at this spatial scale. But look at our county here on the mainland. And I think what you'll see is these huge globs of points representing specimens that are in areas in the front country that make sense. Thousands of specimens right here in Santa Barbara and Goleta. These are roads leading through the mountains. This is, Sierra Madre Road going down the Sierra Madres. These essentially are the well-traveled spots, but there's so many places where no botanist has set her boots before, right? Not a single specimen collected from some of these areas. And that itself is pretty sobering. So what about the Channel Islands? What about the Channel Islands? What are our biodiversity blind spots? What are our botanical black holes out there? This archipelago has been called North America's Galapagos Island, in part because it's this wonderful archipelago, scenic, rugged, and of course, because of the special biodiversity it supports. But what are the blind spots there? So here at the Garden, as a nonprofit, really organized around preserving California's plants and the ecosystems they form, we're responding to this statement. To conserve it, we must understand it. And the argument's really simple. For conservation work to be effective, it has to be based on the best possible data, right? What are our highest priority actions? We can't really answer that if we don't have good data. And given our limited resources, how do we focus? So the question here is, how well do we understand the plant biodiversity of the Channel Islands? Is there a biodiversity blind spot? Is there taxonomic work needed? Are there any botanical black holes where more floristics work is needed? If so, how do we remedy these gaps in knowledge? So, I would submit here that one way forward, no matter what, we just need more energy focused on this problem. We need more work. And one way forward is this current project, the Channel Islands Flora Project. So the Flora of the Channel Islands Project, this is a book project, and it was launched in 2018. It's a partnership with the Nature Conservancy with funding provided by the Seaver Foundation and the Santa Barbara Botanic Garden. And it's really in deep collaboration with island managers and others. And our most stalwart island manager partners are folks from Channel Islands National Park, US Navy, Catalina Island Conservancy, Nature Conservancy. And there's just literally no way to write the number of botanists, conservationists, and taxonomic experts who have either participated directly or who have created the resources that we have leveraged to come up with the summaries and the work that we have so far. So really standing on the shoulders of countless other people here. So the goals of the project, the overarching goal is, it's hopefully to create something useful, an up-to-date resource for identifying and learning about Channel Islands plants, a book. But there's a ton of incidental goals and what we hope are sort of fringe benefits of the project. So we know that any Flora project where data are consolidated, in this case for the Channel Islands, will kind of consolidate that info as of today. It will be a snapshot in time, a baseline, a new baseline. We also have an aim to create and maintain checklists of the California Channel Islands that are available on the internet, can be updated readily. Importantly, we wanted to identify those biodiversity blind spots and botanical black holes and begin to prioritize actions and, in some cases, start to chip away at them. So, it's a tough time. It's a tough time to be alive, no doubt about it. But as a floristician, we've never had greater tools at our disposal and more information at our fingertips. But we have a bunch of great work that Steve and others have done prior to this work that Kristen, Steve, and I are engaging on. Flora of Santa Cruz Island, 1995, Flora of San Nicolas Island, 2008, and published checklists for most of the other islands that are in their own ways very complete. We have really just an overwhelming amount of specimen data that are available to us these days, and more of those specimen data are digital. So they're still physical specimens that live in natural history collections like ours here at the Garden. But increasingly, the label data are digitized into a format that's internet accessible. And at least at the Garden, about half of them have high resolution images associated with them now. And that's really a trend that we're going to see play out over the next 10 years or so as biodiversity collections are trying to get their information out to people who will use it. Those data are pushed to data aggregators, and the Consortium of California Herbaria, the CCH2, presents those data to anyone with an internet connection. This is a plot of all of the plant points for San Nicolas Island, for example. And you can see, well, first off, you can just see the island looks like it's been pretty well collected, ton of specimen data from there. And you can just imagine what a wonderful resource that is to us as we're trying to better understand the flora of the archipelago. Now, something that's recently come online, last 5 or 10 years, is the program, phenomenon, institution, iNaturalist. And this is something that I couldn't have anticipated, but it's really changed the way that I do my job. We'll talk more about that here in a little bit, but these are just iNaturalist observations for Santa Catalina Island. Every single one of these little green dots here represents a place where someone with took out their phone and took a photo and uploaded it to iNaturalist. Really remarkable. And this is, probably just 5 or 10 years worth of data, but you can see the data are so dense that it really traces the outline of the island pretty well. Pretty remarkable. So step 1 in this process was determine which plants to include and make a list. We had a simple decision rule. This is the same decision rule that the Jepson e-flora uses. And that is that we wish to include in our book only native plants or naturalized non-native plants. So your question must be, what on earth is naturalized? And so our definition, again, same as the Jepson e-flora, that there must be a self-sustaining population of this plant in which at least some individuals aren't planted and are themselves producing viable offspring. So as an example of a plant that's not naturalized, a planted peach tree near a historical ranch location, even if it makes flowers and fruits. So that would be not naturalized. Naturalized, a good example of that is Malva asurgensiflora on San Nicolas Island. We know of a population that's in a wild place that wasn't planted. There are multiple mature plants of different age classes, and every year we go there, we find new seedlings. So this is a real example, and here's a seedling that Bill Hoyer documented to help us make this decision. Behind the scenes, there's a checklist. Again, this is the behind the scenes checklist. Yikes, there's a lot going on there. We know from our checklisting efforts that we have about 1,060 total taxa on the Channel Islands right now. And I have this in italics, that I just want to mention that this number is kind of a floating number. As we get more information, as it becomes clear that something's naturalized, it would advance this number by 1, or as new specimens come online, we have more information and we can make better decisions about whether to include something or not. So this is just a slice of 30 or 40 rows. Looks like Boraginaceae through some Brassicaceae, and this is a taxon by island matrix here. This is the Channel Islands and the Baja California Pacific Islands, and every place where there is a color that's different from this kind of celadon sage color is where we've either added something that makes our checklist different from previous checklists, or we have removed something that makes our list different from previous checklists. So kind of a mustard and ketchup look here, and this is very normal. These 40 rows very normal. So the behind the scenes checklist, really a lot has gone into refining it over the years, and it'll be a work in progress. There are cleaned up CCH2 checklists that are available to anyone who wants them. And these are things that we envision maintaining through time. So if you wanted to go there and take a look, you could go to cch2.org. You could go to checklists right here on this bar. When you click into checklist, just scroll down to miscellaneous inventories and select the island that you're interested in here. Not all of the islands have their lists made public yet. Some of them are still private, but I think at least 5 or 6 of them are up there. And this is just the coolest thing about the way that the CCH2 organizes data. The checklisting function or package in CCH2 is really awesome. So we've gone in and built checklists for all the islands. There's some summary data up at the top, and you can have the checklist presented to you in multiple different ways. So you can kind of click in this options menu over here and click build a list, and it'll show you more data, less data. And I think one of the neatest things about this, because the CCH2 is literally where we live manage our specimen data, it is our database. We have access to the checklist function, has access to the literal records that are stored in SBBG or in other participating institutions. So each of these, it's kind of hard to tell, but this text right here is in blue, and those are live links that where we linked vouchers to that particular name that represent that taxon from this island. So if you wanted to know more about it, you can click into this Blakely specimen or this Philbrick specimen or this Leroy Abrams specimen for Mesembryanthemum, for example. So super, super neat. You can print it straight from here. You can kind of custom build it. You can download it in Word. It's pretty nifty. Step 2, once we had a list, I should point out this was a very, very iterative process. But step 2 was to begin generating taxonomic treatments for everything. So this is very much like the Jepson manual, where there's full taxonomic treatments for every family and genus. So this is the genus description for Euphorbia, for example. There's dichotomous keys for everything that we think is naturalized or native on the Channel Islands. So there are keys that would allow you to take your unknown plant, whatever it is, and get down to hopefully a subspecies, variety, or species, whatever's the lowest taxonomic rank for that particular entity. And so we have full descriptions for those two. So that's the step 2 is taxonomic treatments. And that was happening at the same time as Linda Vorbeck, the really wonderful, talented botanical illustrator, was doing illustrations for the book. Although here's a couple of plates that represent some of the process that she uses, which is to take some of her existing line art from some of the other flora books that she's worked on with Steve. She'll make a plate out of them based on the taxa that kind of fit in that part of the in this particular case, the Poaceae or the grasses. So this is a plate that goes from Echinocloa to Earharta. Echinocloa was a new drawing. So this is her pencil drawing that's pasted in place. And she'll submit that to me and Kristen and Steve. We'll look it over, suggest changes, either to the labels or there should be a little bit more hair right here, those kinds of changes. And then she'll ink it. And so every single one of those 1,060 taxa has got a bit of line art that has gone across Linda Vorbeck's desk. And then the last step that we're in now are the introductory chapters. And these are, if you've ever picked up the cruise flora or the San Nic flora, the introductory chapters alone are worth buying the book. These chapters mirror those other 2 books for the Channel Islands flora, and that would be kind of a basic introduction to the Channel Islands, physiography and climate, geology, vegetation, land use history, history of botanical exploration, and a floristic analysis. Our progress to date has been pretty good. Always kind of surprised about how long things take, but the checklists our checklist is good for now. It's under continual refinement, but it's pretty stable. We've been working on the treatments since at least 2020, and the botanical editing has been going from 2019, 2020 through to earlier this year. The illustrations started in 2018 and are wrapping up. We're really, really excited to have them wrapping up next month. And the introductory chapters we're working on right now. So we've been working real hard on this project, and the timeline for completion is right around the corner. So that is the project. What have we learned in the process, right? What are those unanticipated advances, perhaps? So the first thing I'd like to report are just the islands by the numbers. And it's tough for me to tell if you can see up in the corner here, but I just want to highlight this asterisk here, right? This is subject to change as we go, because we know that not everybody will be using the same definition of naturalized. Perhaps other people's lists might be different than ours. And our list will advance as we learn more about the flora, but this is where it's at right now. We've got 1,060 total taxa on the Channel Islands. 729 of them are native and 331 are non-native. So that puts the percent native right around 70% or so for the Channel Islands. Of course, we can tabulate the total taxa for all of the islands, and some of the smaller islands or those with a more depauperate flora have lower numbers. Lowest number for any island is 144 for Santa Barbara Island. And of course, the larger islands, and those islands are much better explored. Santa Cruz and Santa Catalina Island have right around 700 or so, or a little above 700 total taxa. Another way to think of the floras is, what proportion of them are native versus non-native. I mentioned that the global average here for the Channel Islands is around 70% native. So some islands are on the low side. So San Nic has about 55% or so native plants, while Rosa and Cruz have over the average at around 75 or 72.5%. A neat thing about floras, I mentioned they provide a baseline, kind of a picture, a snapshot of our current perspective on the flora of a place. And I've lined up 3 such perspectives. Here in 1995, this is Junak et al.'s Santa Cruz Island flora. There was a checklisting effort by Sarah Rattay and colleagues in 2014, and then our current effort right now. What I hope you'll see if you kind of scan up through these columns going from 1995 through to the present, I think that you'll see a steady trend of increasing numbers of taxa on all of the islands. And usually it's stepwise, but not always. There's two places where the way that we were tabulating differed from what Ratte et al. Were doing, and also some differences in how taxa were interpreted. Totally normal. But in all cases, we've got this kind of increasing trajectory. And it's kind of fun to think about the numerical increase and especially the percent increase. So across these islands, we have anywhere from 12 plants were added. So our knowledge changed. And this is one way of thinking of it, 12 new plants. All the way up to 111 new plants for Santa Catalina Island, which is really just a shockingly high number. The percent increase for two of these islands, San Clemente and Santa Catalina Island, were approaching 20% difference, which is just really staggering. And it's just a fun exercise just to pause for a moment and to think about what could explain the increases on these two islands. And the taxon addition cases really fall into a handful of different categories. One of these, and probably the one that adds the greatest number of taxa to all these islands, are the addition of new non-native plants, new things arriving. And an example on San Clemente Island is the arrival of Cachala australis to that island. Was first documented by Tim Ross in 1995, and then in several places by Steve in 1996. So that was a new addition to that island that inflates that number by 1. But it's not all non-native plants. I mean, the study of the flora of these islands is really resulting in the documentation of new plants, new previously described plants for that island or for the archipelago. A really super exciting and surprising one. This was the result of John Redman and Sula Vanderplank's recent floristic work on San Clemente Island. The addition of Isoetes or Cuddii, which is a heterosporous water fern. If you've not encountered this plant before, they're super charming. They look, on the surface, they look a little bit like a little grass, but when you dig them up, the reproductive structures, the structures that produce spores, are held in these little cases underground. So this is John's photos from his iNaturalist observation showing those structures here. Super cool and really surprising. This was a new archipelago-wide record. We had to go back and add the family, the genus, and the species in for the book. But when you're out there, there are these unanticipated advances that happen. And when John was out there working, he detected some issues with how Cryptantha was parsed out there. Everything was called Cryptantha trasci, and when he began to compare the material that he was seeing on Clemente Island with trasci from San Nicolas Island, he realized there was something different. And in fact, he and Mike Simpson in 2022 created 2 new San Clemente Island single island endemic taxa in the genus Cryptantha, and Clementina is one of them. So I just want to point out, and sorry, that's a little bit of a garish color as I'm looking at it, but I just want to point out that this is floristics and taxonomy that are resulting in our changing knowledge and appreciation for the flora of this island. What about Santa Catalina Island? Same deal, same exact deal. So, our work out there on Catalina Island resulted in, this is just a couple of the large number of non-native plants that we were able to add to the flora. This is Carduus tenuiflorus. This is a non-native plant that was first observed by Steve in 2022, new to that flora and new to the archipelago. Here's Medicago spherocarpos. This is a non-native plant that, according to the Medicago expert up in Canada, this is actually a new North America record of this particular species of Medicago. Now, it's just simply impossible that the first place where that it landed is on Catalina. It must be elsewhere on the mainland flora. But how neat that Steve's work in 2016 documented this plant out there, right? If you're looking, you're going to find new things. So this is in the kind of depressing non-native things were added to the flora category. But again, on Catalina, it's not just that. This is a discovery by Sarah Ratte in 2006, Panicum capillary out on Catalina Island. Really gorgeous, goes by the name witchgrass, I believe, and known from only one location on Catalina Island, but a really cool native plant. And I'll tell you a little bit more about California macrophylla. This is something, some taxonomic work that we're working on now, but the primary insight for it came from working in the stacks, working downstairs in the herbarium, and seeing something different. Again, floristics and taxonomy, and again, apologies for the garish color there. Okay, so one thing leads to another. There's fringe benefits to doing this kind of work, or there's these unanticipated advances that accrue because we're spending time working on the biodiversity of a region. We have spent a fair bit of time out in the field, and that's resulted, as I've mentioned, in new island records. But also I want to point out that fieldwork is not just being done by folks with, a lot of biodiversity training or even biodiversity jobs. The rise of iNaturalist as a platform for engaging with biodiversity and generating biodiversity data is really one of the most interesting, and I think one of the most important things to happen to our field in a long time. So I'm going to sort of combine those and tell you one story here about fieldwork. I'll tell you another story after that about study in natural history collections, focusing on California. And then I'll tell you one more story about the sort of activities that when you're working on floras that are sort of spawned from that work. So let's look at iNaturalist first. Maury, this is the time when I'd love to deploy the poll. There we go. And so the question here is just simply, do you use iNaturalist? And that would mean like you've got it downloaded on your phone, or you upload photos to it that you took on your phone when you get back home. So if you wouldn't mind clicking on either yes or no, that would be awesome. And Maury, I think we could give it like 5 seconds or something like that.
Yeah, are you able to see the results there, Matt?
I cannot.
Oh, okay. Well, it looks like a pretty even split here. We have 56% said yes and 44% said no.
Awesome. Okay. So 56%, I'm still talking to you, but a lot of this is really for the 44%. So I'd like to tell you a story about iNaturalist. I'll just start with what it is. So iNaturalist is a community of people that work on this platform that's called iNaturalist. And their goal is essentially to have fun interacting with biodiversity. The goal is not to generate biodiversity observations that are used by folks like me. That is an outcome, but it is not the goal. So if you are a person who enjoys biodiversity, goes for walks in downtown Santa Barbara or in the backcountry, and you'd like to know more about the world that you live in, consider downloading iNaturalist. It's super easy. You take a photo, you put it online, and believe it or not, like sometimes within 30 minutes, you have people interacting with you, telling you what they think it is. It's really a remarkable way to interact with biodiversity. Now, the upside of it for biodiversity researchers like myself is there is just an absolute tidal wave of information that's contained in those observations that folks like me and folks like you are generating. So right now there's 159,483,973 observations as of yesterday on iNaturalist. This is global. This is not Santa Barbara County. It's global, but it is an absolutely staggering number of biodiversity observations. Just to put this in context, biggest herbarium in the state, the UC Jeps herbaria at Berkeley, has right around 2.5 million specimens. These are focused on plants, and they're largely Western North American and all that. So this is still a huge number, but based on their reporting, iNaturalist over the past 12 months has added 46 million records over just last year. That's 18.4 UC Berkeley's over just last year. So just a huge amount of biodiversity data. And when you plot it over longer time slices instead of just right here, this is an absolutely skyrocketing exponential increase in the observations every year. So just a really amazing resource for folks who do this kind of work. So I track this a lot. This is a kind of data that I'm monitoring all the time for the Channel Islands. And in the course of working on the flora, a record on Santa Cruz Island popped up of Sertomium falcatum. And this was taken, this is house holly fern. It was not otherwise known from Santa Cruz Island. And this was taken by James Bailey. He's like a power user of iNaturalist. He actually has the record for the greatest number of species observed by any human using that platform at 22,000 species observed. But he's got a non-trivial number of observations too. He's just extremely active. But he posted this and he tagged me on it. He said, is this interesting? And this looks like a fern that's taken on a rock wall, right? Well, there's a reason why botanists hadn't collected this thing yet. And that is because it is in one of the world's largest sea caves. So this is Painted Cave. If you kind of squint up here, you can see it's in the northwest corner of Santa Cruz Island. And it is one of the 10 largest sea caves in the entire world. When you go out to Santa Rosa Island, or if you go to Santa Cruz and you make you're on Island Packers and they do a trip over here, they will take their enormous boat. They will take it all the way into this spot. It is scary, but it is also awe-inspiring to take an enormous catamaran all the way into here. But I'm digressing. So this is just an enormous place, not a place where botanists are typically doing their work. As I started interacting with James and one other person who had seen it there, they let me know that they had seen it up here. So this is, I don't know, 80 feet up in a sea cave. As I started getting excited and we started, kind of geeking out, going back and forth, writing comments about it, other people started coming online with their own observations of it and kind of interacting with us. And this actually pulled one person, Devlin Gandy, just sort of recently posted this one. And he found a picture back from 2011 where he saw the plant. So this really pushes our date from where this non-native plant got established out there. So like, what an awesome way that James Bailey's passion for documenting biodiversity resulted in me seeing it. And then, of course, we wanted to go out and collect a specimen. So I'm sorry, this video is, I hope it plays. It's extremely ponderously slow. So this is me on an Island Packers boat with Kristen. This is, I'm leaning over the edge at the top story of an Island Packers boat. They're easing over to this volcanic rock wall. That's a 30-foot long, very light aluminum pole with this really weird little guillotine that we built attached to it. And we were able to finally get there was a decent piece. So this was just on a boat. I had like 30 seconds to do it. The Island Packers people ended up catching it. I didn't know they were going to do that, but like, what an awesome way that community scientists can go explore the world they live in, interact with other like-minded people, and then that drives the generation of specimen data. And we used that, both this occurrence as well as the specimen, as our way to anchor that taxon in flora. So one thing leads to another. And so that's the importance of community science in this whole thing. Of course, we have a rich legacy in our natural history collections of physical specimens, kind of the way we've always done it. And that's resulted in a lot of specimen backlog curation. All of those invaluable specimens, dating back to the 1800s, are all available to anyone with an internet connection on the CCH2. We've used those specimens and referring back to them and checking their identities and to refine geographic ranges. And this is especially true on the Channel Islands for really tough plants like Cuscuta and Cirsium occidentale and others. But what I want to tell you about here, a little natural history vignette that I want to talk about, is the improved taxonomic understanding that we have for certain groups based on new research. And this is just totally incidental to our work, wishing to better understand a problem that we see. And we can't fix all the problems, or all the places where we sense that some research would be helpful, we can't pursue. But this is just a very small list of the genera that we've worked on over the course of this, either doing molecular systematics work, population genomics work, morphometrics, to better understand the flora of the Channel Islands. And I'm just going to land on California here to tell a quick story. So California macrophylla, I wish I could do a poll and ask if who has seen this plant. It's a really awesome little Geraniaceae or geranium relative. Used to be in the genus Erodium. Most folks think of erodium and hiss and boo, but this is an awesome Geraniaceae. This is the way it typically looks. So it's got a tuft of a basal rosette or a tuft of leaves at the base, not much in the way of an above ground leafy stem. The leaves are kidney or heart-shaped. And if you look, the teeth that are on the margin of the leaf are pretty soft, kind of rounded, soft little teeth, and the petals are white. That's a good example of what that plant looks like throughout its range. 9 years ago, I started studying some material that Steve brought back from Santa Catalina Island. We have not processed our material yet. We're still kind of studying it, but we sent material out to RSA of the same gathering, and they have an image of it online that I'm showing here on the left. The very first thing I noticed when I was confronted with this massive specimen that Steve collected was, first off, this thing has real stems. This has a great big stem, and the stems are leafy. Really different from anything I had seen before. It was a real head scratcher. I mean, clearly related to California macrophylla, but a real head scratcher. The leaves are a different shape. The length-width ratio is wrong. When you look at the leaf blade itself, it's no longer kidney shaped. It's got these incisions or these sinuses, or the flip way to think of it is it's got lobes. And if you look at the margin of the lobes, the teeth are sharp. So pretty darn different. Fast forward about 4 years, and the amazing and comparable Adam Searcy was on Santa Barbara Island, and he posted on iNaturalist this particular set of images. I notice again, this is a big beast of a plant. It's got a great big stems. Those stems are leafy. When you look at the leaves, they are no longer kidney bean shaped or kidney shaped. They've got these sinuses, and they've got these more sort of aggressive serrate leaf margins. So pretty weird. Now, a cool thing about California, and I think plays into this, is California is known for losing its petals. And so when you look at specimens, there's almost none that have petals, so you don't know what color they are. It's tough to see that here, but this is a time lapse that's just over the course of a morning. It's tough to see because these are kind of bleached out, but these are pink. This is on Catalina Island from earlier this year, and there's the petals falling away right away. So it's talked about kind of anecdotally that you never find these plants with petals. Well, here comes iNaturalist again to the rescue. When you begin to look at the pattern of morphological variation on the landscape, you find right away plants from coastal San Diego County and coastal northwestern Baja California both have the same leaf morphology as the Channel Islands plants. And lo and behold, they have the different petal color too. So iNaturalist was one of these platforms that allowed us to have this insight, this biodiversity natural history insight that we couldn't have had otherwise, because these plants simply lose their petals. And that's an example of that happening right here, where the petals just happen to be preserved there. So my big but joke here is that California is probably going to get a little bigger as we carve out at least one new taxon here. Again, one thing leads to another. Natural history collections were the first observation 9 years ago, and then iNaturalist is helping us fill in the blanks. And then the last thing I want to highlight, the last story I want to tell, and I'm sorry, this one's a little bit more data heavy, is focusing on specifically on gaps, right? So there's this project that we did in collaboration with the Nature Conservancy called the Channel Islands Gap Analysis. So this is specifically to get us thinking, using specimen data, whatever we could get our hands on, where are the botanical black holes, and to a much lesser extent, what are our biodiversity blind spots? And I'm so sorry for hitting you with a big dense table towards the end of my talk here. One thing we learned is that the islands are different sizes. I wish I could see you, that's a joke. Of course, the islands are different sizes, but when you compare the island sizes, so big islands like the biggest Santa Cruz Island and Santa Catalina Island, they have a huge number of specimens that have been collected there. Correspondingly high taxonomic richness. This is the number of things that were in that specimen database that we were looking at. But you might be saying, Matt, I'd love a correction for island size. And so that's what this is. So we have divided the islands up into 1 kilometer grid cells, and on average, Santa Cruz Island has about 68 specimens per 1 kilometer grid cell. Catalina Island, totally comparable. So where are our biases? Where are these blind spots? Well, it turns out Anacapa and Santa Barbara, huge systematic or surveyor bias towards collecting on these islands. They're itty bitty islands, but have just a disproportionately huge number of specimens collected there. Not hugely biologically meaningful, that bias. It's great that we have that many specimens from there. It's really the inverse that we need to be worried about. So here's Santa Rosa Island, second largest of the archipelago, but with an absolutely miserable number of specimens per cell. And you can see that in if we plot number of specimens against island size. And we have Catalina and Cruz are kind of above this regression line. And then here's Santa Rosa, sadly, a great big island, but with relatively few specimens collected on it. Here's what that looks like in space. Santa Cruz Island, if you squint, like I'm kind of leaning back and squinting, and the island takes on kind of an orangey color. That's because each one of these little orange dots or red dots are specimens here. So you can see, the Central Valley, the road over from Prisoners, major ridge lines that have roads. So just a lot of specimens collected from this area. But look at poor Santa Rosa. Really, right here around the landing, there's a lot of specimens collected from there. This is a really wonderful and accessible stretch of coastline, so a lot of specimens from there. But there are many, many places where no botanist has collected anything on this island. Really, really sobering. So that gap analysis really helped to drive home the point that there are places where some systematic surveying would be really helpful. So this is a similar graph to what Dean William Taylor did for California. This is for each of the California Channel Islands. So this is the number of collections that have been made and the taxonomic richness that ensues, or the number of taxa on each of those islands. And what we'd like to see is a saturation here. We'd like to see the number of collections get to the point where this line flattens out and reaches an asymptote. And that seems to be happening for Santa Cruz Island. That line's pretty flat, huge number of specimens. But here is Santa Rosa Island again, with fewer collections, and it's clear that the taxonomic richness has not been reached, because this curve, you can easily in your mind's eye project it out like this, right? So the species accumulation curves are telling the same story. So what gaps remain and what species are left to describe? Well, Santa Rosa Island is by far the biggest gap. We know that that's a botanical black hole, and that allows us, we're in a proposal stage to work on that island right now with some floristics work. But it's really allowed us to make the case with our island partners that this is an island where additional collections would be helpful. And then all the work on the flora has really revealed the biodiversity blind spots, and we have a huge list of plants that would benefit from some additional research. So here's what we set out to do for the talk. Part one was this biodiversity context. What is basic biodiversity research and why does it matter? What are the current challenges to living things, including humans, in the present day, and what can we do about it? And so I'm hoping that we've gone through and talked a little bit about these things. I'm arguing that basic biodiversity research is one of the things that we can do, but I really hope that it was clear, just bounce back and forth. iNaturalist, this would be a wonderful thing for any of us to spend a little bit of time doing. It's been hugely valuable for me as a scientist, and also just really fun. In the second part of the talk, we went over a little bit about the Channel Islands flora, about the project, and I hope I drilled home the real connection between doing basic biodiversity research of any kind and all of those unanticipated advances that can happen as a result. So this is my last slide. I'd just like to say thanks to you. You had a lot of other things you could have been doing on a Thursday. I'd also like to thank our collaborators, the Seaver Foundation, Nature Conservancy, Catalina Island Conservancy, the Navy, Channel Islands National Park. One of my major life heroes is Dr. Shirley Tucker. I'd just like to thank her for believing in the value of floristics and taxonomy. Too many island partners to name and too many island botanists and taxonomic experts to name, but just know that we did a little thing, they did a lot. If you want to learn more, you can go to the Gardens homepage. You can go to CCH2 to get access to any of our specimens. Let's meet up on iNaturalist. My username is Matt_G. And feel free to get in touch anytime. That's my email address. So that is all I have for now. Thank you.
Great. Thank you, Matt, for the wonderful presentation. That was a really comprehensive overview of the importance of floristic data for increasing conservation on the islands and mainland. We appreciate your time putting that presentation together for us tonight. Oh, is he gone? Let's see. Hold on a minute. Looks like Matt has dropped off, so give me 1 second here.
Hey there, Maury, are you still there?
Oh, there you are, Matt. Thank you. You're back. You dropped off for a minute.
Yeah, my work computer decided to reboot and install some things, so I'm on my laptop.
All right. Well, happens to the best of us. Thank you for joining back on. So if you're ready, let's commence with a brief Q&A here, about 20 minutes.
Yep.
And see if anybody has any questions about your presentation. Thank you for everyone for being patient for that brief technical blip.
Unbelievable.
Well, let's see. Anonymous says that was a fantastic presentation. So it looks like some positive feedback. Linda would like to know if you had a permit for taking the plant from Painted Cave, and wants to remind everyone that you're not supposed to take physical specimens from the islands.
Yeah, so that's a great point. I mean, this is what makes iNaturalist so wonderful, is that any person anywhere on Earth can snap a photo, and in most places that's okay. As you know, a biodiversity focused scientist, I definitely have permits through Channel Islands National Park, but that's actually on Nature Conservancy property, so that's private property. But even in that case, we definitely collaborated with the island ecologist to make sure that it was okay that we collected that plant. So that's a really good point to make, general point to make, and yeah, I'm happy to report that we were fully compliant.
Great, thank you. Dylan asks a question that is on my mind, and I'm sure is on many of our minds here tonight, which is he's wondering when the book will be coming out. Yeah,
unfortunately, we're not able to take any questions from Dylan at this time. So if she would just retract the question, that'd be super. Dylan is the person who slogged through the botanical editing on that book. And so, yeah, Dylan, we're really hoping for next year. The Catalina Island flora, we're hoping to push to is in full layout mode, and we're hoping that goes this year. And then when the intro chapters are done, which we hope is early next year, then the layout person, we hope, picks right up where she left off on the Catalina flora. So I'm hoping for 2024 for that one.
Great, thank you, and good to know about Dylan. I'll make sure of that moving forward. Kai Hoffman says, thanks, Matt. Those botanic black holes are inspiring.
Yeah, is it okay if Maury, could I respond to Kai real quick?
Yeah, go for it. Yes.
Hi, super glad to see you here. Thanks for being here. Hey, all of those points that you're taking in the Santa Ynez, those are filling in botanical black holes. So I would just say keep at it. And sorry we haven't connected on collecting physical specimens yet, but let's do that too.
Great. Well, Anonymous says that the public, I'm not sure what they're referring to, but they say the public cannot go to many of the islands. But what are some ways for an interested amateur botanist to visit the island and and participate in iNaturalist?
Yeah, so the two hardest islands to get to are the two Navy islands. So that's San Nicolas and San Clemente. San Miguel Island, incidentally, San Miguel Island is part of Channel Islands National Park, but is still owned by the U.S. Navy. So it's still a Navy island, but that one you can get to. So I would say, and there's no dock, there's no good way to get to Santa Barbara Island right now, but that's part of Channel Islands National Park and should be accessible to you at some point. So I would say most of the islands, if you're willing to ride on a boat, most of the islands are accessible to you. The only ones that wouldn't be through direct channels would be those two Navy islands. But Maury, you want to tell them about Channel Islands restoration?
Yes, well, we do habitat restoration and volunteer trips out to the islands. So we recently did a trip to Santa Rosa Island last week, and we'll be doing some work on Santa Cruz Island, hopefully scheduled for early next year. So if you'd like to join us in those activities, that's another way to get involved. Or you can also take Island Packers and, as Matt mentioned, visit Santa Cruz, Santa Rosa, and occasionally San Miguel as well. Let's see. Wayne Farron, it's a familiar name here. He wants to know, does your analysis suggest there are gaps in collecting and understanding of particular groups of plants, such as grasses compared to asters, on the Channel Islands, in addition to gaps on particular islands or areas within islands?
Yeah. Hey, Wayne, that's good to see you on here. Yeah, that's a really great question, and I think that bias is definitely there. There's a lot more specimens of ceanothus and oaks rather than grasses. That's a pretty clear pattern. The sort of taxonomic biases weren't an explicit part of the gap analysis, but would be one that's pretty easy to tabulate. I didn't talk about the spatial phylogenetics project either, but that was one, and that's not a fun one to talk about or hear about, because of the methods that are involved are pretty inscrutable to anyone but like the actual coder. But those analyses, which did focus on taxa and specifically on evolutionary groups, revealed the same biases. So certain lineages of plants are disproportionately collected rather than others. And yeah, the grasses versus asters is a good one.
Great. Thanks, Matt. And I'm just wondering, I know you sort of skimmed over it at the end there, but where can people get updates about your work, about the book? What's the best way to reach out to you?
Yeah, so we began an interest list at the last SBBG Conservation Conference, which is we have annually. So we started an interest list there, and if folks are interested and want to know more about when we're gonna publish the book, feel free to email me directly. And let's see. Oh, that's my computer mouse, not my laptop mouse. And I'll just, I can't tell if, oh, that just says host and panelist. How can I, let me see, I'm going to.
If you chat to me, I can share with everyone.
Okay.
Yeah. We have a few more minutes here for questions. If anyone has any other questions, close out the night. And I'm sharing Matthew's email if you would like to contact him directly. Parker Villalobos would like to know if there are any plans for Santa Barbara Botanic Garden collections on Santa Rosa Island, which I think you sort of briefly touched on at the end there
Yeah.
of your talk. Yeah.
Yeah, Parker, how's it going? Nice to see you on here. The work that I alluded to, so I'm working on a proposal that we'll submit to a private foundation in the next couple of weeks. And we sort of pre-pitched the idea, the sort of botanical black holes problem of Santa Rosa Island to the foundation, and we know that they're really receptive. So it'll end up being something like a 3-year project. We hope a 3-year project if it ends up being a worthy proposal and they select it. And the idea is really basic biodiversity exploration. We're going to raster out the entire island and very systematically visit a prioritized set of 1 kilometer grid cells. And we'll also partner with Cal State Channel Islands, who has the research station out there, and hope that we can get student community scientists involved. Most of our documentation will be physical specimens, but we hope that their involvement would be using iNaturalist.
Great. Thank you for that answer, Matt. Let's see, Carol Gravel. Hi, Carol. Nice to see you tonight. Would like to know if Steve Junak, and I don't know if Steve, you're on this webinar, but if Steve's previous book is still in print or available. I don't know if you know that, but
I do, yeah. So I can, and Steve, if you're on, feel free to fill in too. But this, so this book, the San Nic Flora, is totally still available. It's available print on demand. It's also available in our bookshop. So this is an awesome book, and it's a super value too. I think it's maybe $30. Totally worth getting. And then the cruise flora, this one, all of the the reason why this one is so expensive is all of the backstock burned up in the Hesosita fire when so we lost a lot of the backstock of this book. So there's not as many copies out there as you might like. I would just create an alert on eBay for it or on Amazon for it for when it drops below some threshold that you find acceptable. Sometimes you go on there and it's like $400, so that's not acceptable. But I don't know, Steve, are you on there, Steve? And do you have any other ideas?
it doesn't look like Steve's on the call. I can also loan you my copy, Carol, if you'd like. So that's another option. All right, let's see, a couple more questions. Anonymous wants to know if you expect there to be any more undescribed plant species on the islands, and are you working on them?
Yeah, so I can think of 1, 2, 3, 4, and that includes California. There's 4 that we're like slowly gathering data for. There's a 5th potential kind of diversification across the islands that we're beginning to work on using high throughput DNA sequencing. That one doesn't have as explicit a hypothesis behind it, other than a hint in a Sherwin Carlquist book, Island Life, which is a fabulous book if you've not read it. But Sherwin suspected that the island tar plant, Dionandra clementina, is diversifying across the islands. So that's one where I haven't seen the morphological differences, but he did. And so we're going to be investigating that using sequence data. But yeah, I would think, if I go back and look through my notes, I think it's probably 5 to 10 undescribed things.
Right. Okay. Let's see. Valentine Arvizu would like to know if seeds have been collected and stored in germplasm at the Santa Barbara Botanic Garden, macrophylla, for conservation purposes.
Yeah, Valentine, that's a super great question, and it's I think the answer to that is no. So we do have a Center for Plant Conservation seed bank here at the garden, and an ultra active rare plant program that is adding seeds of rare plants across California all the time. I don't believe this is one that our group has seed banked though, and I would be totally shocked if they had seed banked the new thing, the kind of the Channel Islands and coastal northwestern or coastal kind of southwestern North America taxon, I would be shocked if that particular one had been seed banked. But it could really use it. I mean, it's only known from a couple, one spot-ish on Catalina, one spot on Santa Barbara Island, and just, I don't know, 3 other spots in from the Santa Monica Mountains down to San Diego County, and then like 2 spots in northwestern Baja. So it's a really rare plant.
Great. All right, well, we have time for 2 more quick questions here. Let's see. One is a comment and a question from Andrea Adams Morden, who says she hopes you will have a book lecture and signing at the garden when the book is published. I'm sure we would all enjoy that.
Yeah, that's definitely I think all three of us would rather be out hanging out in the field and looking at plants than doing a book signing, just because of our personalities. But the way that we'll get through the book signings is by looking forward to seeing good people like you, Andrea. So it's been a while since we've seen each other. So it'll be nice to catch up with folks. And yeah, I assume we'll be doing that.
Great. Another recognizable name here. Okay, and the last question is, what is your favorite island and why? Sort of open-ended, but maybe you can tie it into your floristic data.
Yeah, so the 2 islands that have made the greatest impact on me, and I'm sure this is, if you ask me this in a couple of years, I'm sure my answer will be different, but I visited San Nicolas Island more than any other. And it's a really rugged, special place. Doesn't have the largest number of plant taxa, but it's just a fascinating kind of windswept. Its character is just very different than a lot of the other Channel Islands. I really like San Nic. The other place I've been that was really made an impression on me was West Anacapa Island. I don't know how easy it is for people to get there, but for us, we took a boat and then skiffed over, and you kind of leap out onto the lava rocks and cling on and climb up. And it's, it's just a dramatic landscape. Getting up there is, you're kind of walking up the side of a pretty steep slope. And when you get up there, you're walking on a knife edge, walking across, going across the island. And it's just a really, really neat landscape, and it's one that's changing a lot. Anacapa, if Steve was on here, I think he would probably tell you that East and Middle Anacapa have changed more as islands than any of the other islands, and not in a good way. A lot of the islands, the trajectory has been one of recovery after introduced animals were removed. Sheep and goats and cows and all that. Ken is saying, please remind folks, West Anacapa is closed to the public. I guess that's probably Ken Neeson or Ken Convery. Thanks, Ken. Yeah, West Anacapa is closed to the public. We were there with Park Service staff. But the Middle and East Anacapa have appear to be changing as additional seabirds as those populations of seabirds are recovering. It's really having a strong impact on the flora. So it's great that the seabirds are recovering, pelicans and gulls and cormorants and stuff, but they're having an impact. And I never saw those islands when they were in their prime, but maybe at some point Steve can tell us about that.
Great. Well, it sounds like the community really enjoyed your talk, and we both saw a lot of familiar faces tonight. So we will look forward to updates regarding your book. If you'd like to view this webinar or any of our other webinars, it will be available in the coming weeks at cirweb.org. There you can also find news regarding our current work and other upcoming events. So thank you again for your time, Matt, and to everyone who joined us tonight. And we hope to see you all very soon.
Thanks, everybody. Thanks, Maurice.